Let's solve this question using the method of Lagrange multipliers. So this question would like to know what the maximum and minimum of this function, which is x squared y, what the maximum and minimum of this function is subject to the constraint that x squared plus 2y squared must always equal 6. So the first thing I'm going to do when I'm doing a Lagrange multiplier question is I'm going to write down the function I'm trying to maximize or minimize, which is f of xy is equal to x squared y. And I'm also going to write down the constraint as some function g of xy. And I find that by essentially moving every part of this constraint over to the left-hand side of the equal sign, so x squared plus 2y squared minus 6. So that's what I'm going to use for my function g, x squared plus 2y squared minus 6, because I've moved the 6 over. I've moved everything over to the left-hand side of this equal sign. That is what I'm going to call g. So there's my, my function I'm trying to optimize and the constraint, g. So I create kind of my master function here, capital F of xy. And that is just going to be the thing I'm trying to optimize, the function I'm trying to optimize, just f of xy here, so x squared y, minus lambda, which is some unknown variable, times this function g that I have, so x squared plus 2y squared minus 6. So this is going to be my master function f, and the next part of the method of Lagrange multipliers is to take these partial derivatives of f and of capital F and set them equal to 0. So the partial derivative of capital F with respect to x is 2x from the first term minus 2x lambda from the second term. The partial derivative of capital F with respect to y, actually I missed a y here. The partial derivative of capital F with respect to y is just x squared minus, this is going to be 4y lambda from the second one there, in the second term. And the next, or the last partial derivative, the partial derivative of f with respect to lambda is just going to be negative x squared plus 2y squared minus 6. Okay, and the method of Lagrange multipliers tells me that I have to set each of these equal to 0. So this is going to give me equation 1, which is 2xy minus 2x lambda is equal to 0. That's equation 1. From here I have equation 2, which is x squared minus 4y lambda is equal to 0. And from here I have equation 3. And in equation 3, because I'm setting it equal to 0, this is completely equivalent to x squared plus 2y squared minus 6 is equal to 0. So what I did there was I set this equal to 0, but then I just multiplied both sides by negative 1, and you arrive at this. So here are my three equations. I have to solve these three equations for the three unknowns x, y, and lambda. So let's get started on that. So from equation 1, actually I'm just going to write it this way. From 1, I find that 2xy minus 2x lambda is equal to 0. So the first thing I'm going to do is I'm going to divide both sides of this equation by 2. And so I'm left with x, y minus 2x lambda is equal to 0. Of course, if I factor out a common x, I get x times y minus 2 lambda, which means either, oh, that 2 is not supposed to be there. I divided both sides by 2. Okay, so let me start again. I get xy minus x lambda from equation 1 is equal to 0. If I factor both of those x's out, what I end up with is x y minus lambda is equal to 0. And there's two possibilities here. Either x is 0, so this means either x is 0 or y is equal to lambda. So I have two choices here, and I'm going to obviously choose each of them, but I'm going to break it down into subcases. So in case 1, or I'm just going to break them down into cases. So case 1, I'm going to choose the first possibility, that x is equal to 0. Okay, if x is equal to 0, then I can put this actually into, equation, say, 3. And in equation 3, if I put in x equals 0, what I get is that 2y squared minus 6 has to be equal to 0, which means that y squared has to be equal to 3, which means y has got to be equal to plus or minus the square root of 3. Okay, so now I know that x is 0, and I have two choices here for y, so I'm going to break those two choices down into subcases. So subcase 1, I'm going to choose the first one. Y is equal to the positive square root of 3. If that's true, and I've chosen x is equal to 0, if I plug that into here, into equation 2, so into equation 2, what do I get? I get 0, I get minus, so x is still 0, so x squared is 0, minus 4 root 3 lambda has got to be equal to 0. Well, the only way to get negative 4 root 3 lambda to equal 0 is if lambda is equal to 0. So this is solution 1. Solution 1 is that x is equal to 0, y is equal to positive root 3, and lambda is equal to 0. Okay, subcase 2. So I had the choice of the two different y values. So let's choose the other y value now. Subcase 2, y has got to be equal to negative root 3. So if I use this into equation 2, what do I end up with? In equation 2, I have negative root 3 for y, I have 0 for x, so this becomes positive 4 root 3 lambda equals 0. And the only way to make this true is if lambda again is equal to 0. So solution 2 is x equals 0, y equals negative root 3, and lambda equals 0. Okay, so case 1 is done. I've chosen x is equal to 0, and I had two choices for y. I broke it down, I chose each of them, got my solutions. Now I'm done with case 1. Now I'm done with the situation where x is equal to 0. Now I do my other choice from the original choice I had. Now I choose that y is equal to lambda. So case 2, let's choose that y is equal to lambda. Okay, so what do we do now? I want to choose y is equal to lambda. So what I'm going to do is I'm going to plug that up into equation 2. So let's put that into equation 2. And from into equation 2, if I choose that y is equal to lambda, wherever I see a lambda, I can put a y. So I have x squared minus 4. Now I have a y, and because I'm choosing that lambda is also equal to y, I have y times y, which is y squared. So I have x squared is equal to 4y squared, and that's got to be equal to 0. Which means that forces me to admit that x squared has got to be equal to 4y squared. Okay, so let's take this. I'll maybe call this equation, say, 4. This little piece of information now into equation 4. So take 4 and put 4 into equation 3. So here I have a relationship between x squared and y squared. So here I also have a relationship between x squared and y squared. So I'm going to put, wherever I see an x squared, I'm going to put in a 4y squared. So I have 4y squared plus 2y squared, got minus 6. So 4y squared plus 2y squared minus 6 has to be equal to 0, which means 6y squared has to be equal to 6, which means 6y squared has to be equal to 6. Dividing both sides by 6, I get y squared is equal to 1, which means y has to be equal to plus or minus 1. Okay, so now if I do subcase 1, let's choose y is equal to 1. If y is equal to 1, I know from equation 4 that x squared equals 4y squared. So x squared equals 4 times 1 squared, which means x squared is equal to 4, which means x is equal to plus or minus 2. Let's just scribble this out here. X has got to be equal to plus or minus just 2, not the square root of 2, just 2. Okay, so that gives me a couple, so now I have the situation where y is equal to 1, x gives me plus or minus 2, and lambda is equal to y, because that's what I actually started with in this case. So in this situation, I have two more solutions. Solution 3 is that x is equal to 2, y is equal to 1, and of course, I started this case by assuming y was equal to lambda, so lambda is also equal to 1. But I have solution 4 as well, and that is x is equal to minus 2, x is equal to negative 2, y is equal to 1, and lambda is equal to 1. Okay, great. So that was subcase 1. That is where I chose what y could be. That y was actually positive 1. So here's subcase 2. And that is choosing that y is equal to negative 1, because I had two choices up here. So if I choose y is equal to negative 1, what I end up with is x squared equals 4 negative 1 squared, which means x squared is equal to 4, which means once again I have that x is equal to plus or minus 2. So I get two more solutions, solution 5 and 6. Solution 5 is that x is equal to 2, y is equal to negative 1, and that means lambda is equal to negative 1 as well. Solution 6 is that x is equal to negative 2, y is equal to negative 1, and lambda is equal to negative 1. Okay, so I have all of my solutions here, 6 of them, 1, 2, 3, 4, 5, and 6. And now what I'd like to do is figure out what the value of the function is at all of these places. So from solution 1 all the way back up here, I have that x is 0 and y is the square root of 3. So f is 0, y is square root of 3. From solution 2, I have x is 0, y is negative root 3. From solution 3, I had that x is equal to 2 and y is equal to 1. From solution 4, I had f is equal to negative 2, y is equal to 1. And from solution 5, these are the new ones that I just calculated, x is equal to 2, y is equal to negative 1, and x is equal to 2, negative 2, x is equal to negative 2, and y is equal to negative 1. So let's figure out what the function value is at all of these places. So the function that I'll remind you is x squared times y. So x squared times y, when x is 0, that gives me 0. X squared times y, x is 0, that gives me 0. Okay, x squared times y here, 4 squared times 1 is 4. Negative 2 squared times 1 is 4. And here I have x squared times y again, only I have 2 squared times negative 1, that's negative 4. Negative 2 squared is 4 times negative 1 is negative 4. And so what we find is the maximum of f is equal to 4, and the maximum, or the minimum, so the max of f is equal to 4, and the min of f is equal to negative 4.